Good morning, everybody. Glad to see you all here at the lovely hour of 8:30 in the morning. It's a tad early for me. So my contact info is up there on the screen. Welcome to Microsoft SQL Server Management Basic for non-database administrators. So I am Denny Cherry. My email address, mrdenny@dcac.co. My Twitter username is Mr. Denny, if you want to hit me up on there as well. Some housekeeping points. Let's see here, make sure cell phones are off, because they do tend to make a lot of noise in these big rooms, and really I don't care about the rest. So again, here's my contact info. I am a Microsoft MVP for the SQL Server product. I'm a Microsoft Certified Master for SQL Server 2008. I've written lots of books and lots of magazine articles, which basically means I have zero free time whatsoever, other than coming to conferences and hanging out with you guys. So here is our agenda for the next 74 minutes even. We're going to talk about files, file groups, and disks. We're going to look at backups within the environment. We're going to look at what recovery models are and what these mean to you and how these work with backups. We're going to talk about some database maintenance that you're going to want to be doing. We're going to talk about data compression. We're going to talk about corruption, how to find it, how to fix it. We're going to look at compatibility levels, and then we're going to talk about indexes. So before we get started, where are my systems admins? I know it's early, come on. All right, about half of you. Developers? A few of you. DBAs that are confused and think this is a high-level session? No? Okay. People that are just wandering in thinking they can buy a Microsoft Surface in here? A couple of people? Okay, cool, good. You're in the wrong place. That's down by the building too. Yeah, so it was really funny when I give this presentation in North America, then we'll get started. I presented on the second day. So when we were in North America, you were buying your Surface on site, and they were actually handing it to you. So there was a 4-hour line to buy the Surface. So you had to pick what you wanted to do, go buy a Surface or sit in a presentation. Fortunately, my session was late enough in the day that everybody had their Surface. So I actually had attendees. But it was very confusing for a lot of people to just stand in line at a conference all day. So files, file groups, and disks. So the way SQL Server works is we have disks, we have files, and we have file groups. These things all kind of work together as how we're going to physically lay out our data on the disk. This is a very squeaky stage, and I'm sorry. So the first thing I want to talk about are the file groups. So file groups are a logical construct within the database. And we use the file group to group files together, and we put objects into file groups. The reason we do this, instead of saying I want to create a table on a specific file or on a specific hard drive, is because we need the ability to spread specific tables out across multiple hard drives. So in today's world, this doesn't make a whole lot of sense a lot of the times, because we have really, really big hard drives. I can present a 10 terabyte LUN from a storage array to my SQL Server, no problem. If we think back a few years, back to the SQL 2000, SQL 7 days, we couldn't do that. Presenting huge blocks of storage just wasn't possible, because we just couldn't have them. So if you think about back in those days, we had lots of the little like 8 gig hard drives and 16 and 32 gig hard drives and stuff floating around. So we needed to be able to store tables that were maybe 20 or 30 gigs across lots of these hard drives. So they came up with this file groups concept, so that we can put a table into this file group. That file group then has files created on multiple hard drives, so that we can actually create one large object that's going to be spread across all these files. So the files are what hold the actual data within the database. There's always going to be a couple of files within the database. There's going to be a master data file and a transaction log file. Those are the minimum files that we're going to have. Those files are obviously going to be created on hard drives or on disks within your server. Those will be your traditional storage. Like I said, each database is going to be made up of at least 2 of these files. There's the data file, which is going to be the MDF, or the master data file, main data file. If anybody says they actually know what that file extension means, they're actually lying, because nobody really knows, because that's left over from Sybase 30 years ago. And then we have one transaction log file. These are the minimum number of files you need for every SQL Server database. So you're always going to have these 2 objects floating around. Now we can have more than this if we need it. So we can add more data files into the database to either make the database grow bigger or to improve performance of the database. So when I've got these data files, I'm sticking them into a single file group. SQL Server is going to use what's called proportional fill to try to balance the workload across these data files. So if you've got one file group in one database and you've put 4 data files within that file group, and all those data files are on the same hard drive, you're not really doing yourself any benefit because you're not getting any better performance out of the system. There's a myth running around that says that you will want one data file per CPU in the server. That is an old myth, and it is wrong when it comes to normal user databases. You really only need one data file for the database or for the file group. You're not going to get any performance benefit just by having multiple databases on the same hard drive. Now, if you have several hard drives or several LUNs that have been presented to the server, and you create one data file on each one of those, then you'll get some performance benefit because now you've got more spindles underneath your database. So that makes sense at that point. So let me go ahead and flip over. So I have my lovely Microsoft Surface that I purchased for a very small amount of money at TechEd North America, running SQL Server 2012. So this was actually installed a couple of days ago. So here we have just a few databases. Oops, sorry. So the one thing you'll notice when you buy your Surfaces is there's no right-click button on the keyboard. Come on. There we go. And the pen is wonderful. So here we have the files within the database. So if you've created a database or looked at the properties of a database, you'll have seen this screen before. So it's just the database properties window. As you can see, we have 2 files listed there. We've got the AdventureWorks data file, which is the one that says file type rows. And then we've got the AdventureWorks file, which is the transaction log file, which is the one that says log. Now, normally I'd want to put these 2 data files on separate LUNs or separate hard drives. My data file, I'm typically going to want to put on either RAID 5 or RAID 10, depending on how much write I/O I need to accept. And my transaction log file, I'm pretty much always going to want to put on RAID 10. Clicking on that monitor is not going to help any. So as we scroll over, you can see you've got some database growth settings that you're going to want to set. The first thing you're going to want to do whenever you create a new database within your environment is you're always going to want to change these settings. These settings are wrong by default. The reason they're wrong by default is because you're getting them from the model database, which is set with really, really small file sizes and really small growth settings so that we're not wasting space on the DVD and so that we're not wasting space on your system when we deploy this new thing, these new databases. So simply click the ellipse button and change. You're going to want to change those growth settings. The first thing to change is the transaction log at 10% growth. You're going to want to bump that up to about 1 gig or 2 of transaction log growth. Now, the reason you don't want to go any bigger than that is because when growing the transaction log file, whenever we make that file bigger, we have to write zeros to the entire space that we've allocated as one large command. So when we do that, that obviously takes time. So if we set our transaction log to grow by 20 gigs, I have to write 20 billion zeros to the hard drive. I don't care how fast your hard drive is, that's going to take time because it's a sequential write. So even if you're using something like a Fusion IO card, that's still going to take a few seconds. And with AutoGrow, what happens with the AutoGrow is that's going to happen when the file fills up. So the file fills to 100% full, the next user comes in to change data, and then the system goes, oh, well, I need to grow this data file. So that user's command cannot be completed until that AutoGrow event completes. So the user comes in, says, I need to grow the data file or the transaction log file. The transaction log grows by 20 gigs. The application times out at 30 seconds. That's the default .NET timeout. And then the transaction rolls back. And so the AutoGrow command also rolls back. So we end up trying to do it over and over and over again. So that's why we need to keep that growth setting relatively small, but not too small, because having that file grow at too small of a setting can actually cause performance problems when doing inserts, updates, and deletes, and when restarting the SQL Server. And obviously we want to prevent as many performance problems as we can. The data file is currently set to grow at 16 megs, so that's going to be actually that's not the default. The default is 1 meg. Microsoft changed it for the AdventureWorks database. That number you can set to a relatively large number for the data files, provided that you have instant file initialization turned on. That's going to be a Windows operating system setting that you can turn on, and it's called, in Windows, it's called perform volume maintenance tasks. If you have that on and then restart your SQL server, you will then be able to auto-grow your data file without writing zeros to the data file. So if we need to grow it by 50 gigs in one chunk, we can do that, because it only takes a split second. Now, no matter how slow your hard drive is, because we're not actually writing data to that data file. The transaction log does not obey that setting. It always writes zeros. So that's something to keep in mind as you're setting these growth settings within your database. Here on the file group screen, you can see we've got only one file group created. There's always going to be one file group because we need somewhere to put that initial data file. By default, it's called primary. I can change it if I want. Realistically, there's no reason I actually need to change it. Now, if you want conformity within your environment and you want to change these names to match the database name or something along those lines, or match some sort of standard, you can certainly do that. There's no risk to doing that. There's no benefit to doing that. So see here, it just says how many files there are, if it's a read-only file group, or if it's the default file group. What the default file group setting means is that if I create an object and I don't specify what file group to put it in, this will be the file group that it goes in. So when I do a create table, give it a name, specify the columns, hit execute, it's going to create it in whatever file group is marked as default. Or I can specify on and then the file group name. So it all depends on whether or not you want to, or where you want to put these objects when you create them, as to whether or not you check that box. So backups. There are 3 basic kinds of backups that we're going to deal with within SQL Server 99% of the time. Full backups, differential backups, and transaction log backups. So I'm going to start from the bottom and then talk up. So the transaction log backups, these are going to take the data out of the transaction log file and save it onto a backup file. So this is a record of every change that's happened to the database. When I change data, we use a 2-phase commit. I write the data to the transaction log. Once it's written to the transaction log, I can then make the changes to the actual data pages within the data file that contain that information. So when I add a new row, I first add it to the transaction log, which is just appended to sequentially at the end of the log file. And then I go find the actual data page that is going to contain that row, and I put the row in that data page. SQL Server then later goes and actually modifies that data on physical disk. It does all that initial data change in memory. So when I'm backing up the transaction logs, all I'm backing up is the record of the fact that what was changed. It's not the actual data page that was changed. Now the differential backups, these are backing up actual data files out of the database. So whenever I go and make a change to data, I obviously am changing data pages within the database. SQL Server records what database pages have been changed. So we do all our data in 8K pages, which are stored on the physical disk. Those 8K pages are made up of, are grouped together in what are called extents. Those extents are 64K in size. Whenever I mark a change as having happened in the database, I'm simply marking that I've modified the extent. So if I change a bit flag or a Boolean from true to false, 0 to 1, and when I go to do my differential backup, I'm backing up 64K of data because I made that one bit change on the system. The differential backups are going to be done based on what the database looked like, or all the changes to the database rather, since the last full backup. So I take a full backup, every differential I take from there is just, the system's just growing and growing and growing. We don't have incremental backups that you would normally see at the Windows file system level or at the operating system level. We have no concept of an incremental. So when you do a restore, if you're going to use differential backups, you would restore your full, and then you would restore your latest differential, and then all the transaction logs between the differential and when you want to stop. Now the full backup is the full database backup. It is everything in the database as of the time that the backup completes. It's not as of when the backup starts, but when the backup completes. So SQL Server literally just copies all the data into a backup file, and then just dumps the transaction log into that backup file and just leaves everything in there. So the longer your database backup takes, the more space you're going to need in your transaction log file, because you need to be able to log and keep all the transactions in the transaction log file for the duration of that database backup. So if your database backup takes 7 hours to process, you need enough room in that transaction log file to store 7 hours worth of transactions, because you have to keep all of them for the duration of that backup, and then it'll push them all down to the disk. Now there is an advanced backup option called file group backups, which I'm not really going to dive into all that much. I just want to say that it's not used typically for online databases, for production database applications. Where you would use file group backups typically is in your data warehouses. Now, these come in handy because I can back up a piece of the database, and more importantly, I can restore the database piece by piece. So if I've got a data warehouse, and I've got my primary file group that has my system objects, which are basically the definition of all my tables, and then I've got another file group that contains all my fact tables, or maybe I've got one file group per fact table, and then I've got one file group with all my dimension tables, which are like names and colors and sizes and numbers and stuff like that. In the event that my database crashes, I want to get bits and pieces of this database up as fast as possible. So what I'll do is I'll restore the primary file group, that gets all my object structures back into place, and then I can restore each of the individual file groups independently. So odds are I want to get those fact tables restored as quickly as possible. So I'll restore all my fact tables first, and then I'll restore my dimensions. This also comes in handy if we lose a specific hard drive. So say we've got our fact tables on one drive, or maybe we've got one fact table per hard drive, and then we've got all our dimensions off on another hard drive, and we lose the hard drive that contains one of, let's say, the customer fact table, and that hard drive fails. Well, we don't want to restore the entire database to get that back. We're going to restore just that one file group that contains the data that's missing and bring the database back online. Whenever you're doing database backups, always make sure they're being copied off to another machine or to another device. We never, ever want to put the backups or leave the backups on the same machine that the SQL Server is running on. Hopefully this makes sense and is obvious. We don't want to do this because if the machine fails and we lose the entire box, we've now just lost our backups as well, which we obviously don't want to do. So if you're backing up to a SAN, hopefully you've got somewhere else you can back up to. A NAS, another SAN device, something else that's another device within the environment that's not dependent on the actual production SAN that your normal data is going on. Maybe you back up to a virtual tape library and then to physical tape and get it off-site that way, or in some way get it off of the same physical box. And I talked about this for the most part already. So like I said, the full backup is going to be a point-in-time copy of the backup as of when that backup completed. So that's the point in time it's going to be. If we need to restore to a specific point in time after that, that's when we need to start applying our transaction log backups to the full backup that we've restored. Typically, full backups are going to be done daily, maybe weekly. If you're using differentials, you might do your backups weekly. You're not going to want to do them any less frequently than that. The reason for that is because it takes a long time to apply differentials and transaction logs, because there's a lot of data processing and data change that has to happen in order to roll all these other backups forward. So we don't want to depend on having lots and lots and lots of these transaction log backups. I heard about one customer once. They took a full backup when they built the system, and then all they took is differential backups every day, and then transaction log backups. So when it came time to actually restore the system because there was a problem, they had to go find the full backup that they had taken umpteen years earlier, which they thankfully in this case were able to find and restore. There was another case that Paul Randall from SQLskills.com had where it was a bank, and they had a full backup and then they had transaction log backups for about 3 years. So they went and got their full and restored it, and they started rolling forward transactions and transaction logs. 3 years worth of transactions in this bank. After about 2 weeks, the government stepped in and said, you are no longer a bank. You are out of business. We have some pesky little laws in the United States that relate to banking. One of them is that customers have to have access to their money, and they can only be closed for no more than 24 hours at any one time. So seeing as how the central computer for the bank was closed for 2 weeks, they were a little out of compliance. So the government had to step in, shut them down, issue credit to all the customers so that they could at least buy groceries until the system came online and they could figure out how much money everybody had. It was not pretty. So going along with backups are the recovery models. There are 3 recovery models in SQL Server. There have been 3 recovery models in SQL Server for the last 25 years. There will probably be 3 recovery models in SQL Server for the next 25 years. There's not really any need to change these. We have simple, we have bulk logged, and we have full recovery models. So the simple recovery model simply tells SQL Server that we're not going to keep our transaction log history. Every command is still logged, just like it would be normally in full recovery model, but we're only keeping those transactions in the transaction log until we've actually verified that the data has been written to the hard drive. Effectively, once the checkpoint process runs in SQL Server, which is what flushes all the pages down to the disk and verifies they're all written to the actual physical hard drive, at that point, once that's done, SQL Server will then simply go through and mark all the transactions in the transaction log as no longer being necessary for recovery. So we're still logging everything, we're just not keeping that log. With the bulk recovery and full recovery models, now we're actually keeping all our transaction log history until we actually back it up. So there is a little bit of difference between bulk logged and full recovery. With full recovery model, every transaction is written and every transaction is what's called fully logged. So any change that's made, there's a log record associated with it, and all the data is associated with that command. With the bulk logged recovery model, most commands are fully logged. So all your normal insert, update, and delete commands, those are all fully logged operations all the time. With bulk logged, things like bulk loading or bulk insert. So if you're using the BCP command line application or using the bulk load operator within your .NET application, you'll load data through a bulk command. Those operations are what's called minimally logged. What minimally logged operations are is we simply are logging the fact that we've allocated pages to an object, but we're not logging the change that's made to that page. So what that means is if I get a data file that's got 10 rows in it, and I bulk load those 10 rows into the data file, into the database, and I allocate a new page as part of that process, there's going to be a record in the transaction log that says, hey, I've logged this page. This page now belongs to this table, but I'm not going to write what those 10 rows were that are allocated to the table. So the problem with the bulk logged recovery model is I can't do point-in-time restores when bulk operations are happening. So if I've got a system where I'm constantly bulk loading data and I'm using the bulk logged recovery model, I'm basically never going to be able to do a point-in-time restore. Because we don't have the full timing of all these bulk logged commands, we can't do a point-in-time restore because we don't know when all these changes were happening and we don't know what changes happened. Now, we might think that this may cause problems when we're doing transaction log backups because we've got transactions that are happening, but we're not logging those actual transactions. So the way SQL Server gets around this problem is when you do a transaction log backup and a bulk operation occurred as part of that window of time that the transaction log covers, SQL Server actually backs up all the data pages into the transaction log file. So if I do a bulk insert and I insert 1 million rows into my table, I allocate a couple hundred pages. There's a couple hundred records in the transaction log. My transaction log is going to be very, very small. When I go back up that transaction log, that backup is going to be incredibly large compared to the size of that transaction log because I need to actually put all these 64K extents into the actual backup file. So that's how we handle actually being able to do the recovery. In the full recovery model, everything is logged. So all we're doing is just simply backing up transaction commands. So the recovery model is used to control the amount of logging that we have and the amount of recoverability that we have as well. So the reason it controls the recoverability is because of either full restores only, or full and differential restores only with the simple recovery model, or point in time and how close to point in time we can get between bulk logged and full recovery model. Typically in a production environment, all your normal OLTP applications, all your online production applications, line of business applications, those are going to be in the full recovery model. Things like your data warehouses, reporting systems, those are going to be in simple or bulk logged recovery model, depending on what your requirements are for recoverability and high availability. Yeah, I talked about these. I think I covered all the points. Let me see here. Oh, yeah, that bottom bullet point for snapshot recovery model, or simple recovery model, rather. A lot of people think simple recovery model, and yes, I understand the title slide is wrong. Sorry. A lot of people think that this disables logging within SQL Server, and it doesn't. This is a very important thing to keep in mind. You still need that transaction log file because we're still going to be writing to that transaction log file. So even if you're in simple recovery mode, you still need the ability to write to that transaction log file just as fast as you would in any other recovery model. There's a little less work that's done because we don't need to do quite as much stuff when it comes to bulk operations and stuff like that. But we still do need to write all our insert, update, and delete statements to the transaction log file before we actually write them to the data file. We talked about all that. Yeah, we talked about all that as well. So restoring data. When we have database corruption or when servers fail or hard drives fail, obviously we need to get our systems back up and running. The first step in any recovery process is going to be the full database restore. We have to start with a full database backup. If we don't have a full backup and all we have is transaction log backups or differential backups, this is when we need to take the next most important step in our career and start printing up copies of our CV and start sending that around. Because the boss is not going to be happy. Once we've done the full backup, once we've taken the full backup and processed the restore, we can then restore any differential that we need to. So if we're using differential backups, we can then restore at this point. Now again, we only need to restore the most recent differential. We don't need to restore all of them because all the data that's in one diff is going to be in the next one as well. So if we take a full backup every Sunday at midnight, and then we do differentials the rest of the week at midnight, Monday, Tuesday, Wednesday, Thursday, if the system fails on Thursday morning, at say 5 a.m., all we restore is the full backup and then the Thursday morning midnight backup, differential backup. Because that Thursday differential is going to hold all the changes from Wednesday, Tuesday, and Monday as well. So you'll see your differentials slowly growing in size or quickly growing in size depending on your system throughout the week as you're taking those backups. Once the differential is done, we can then restore our transaction log backups. So we simply take the first one that happened after the differential backup was done, and we restore that one, and then the next one, the next one, the next one, the next one. Just restore them all in sequence. If we lose one, or if one is corrupt, we stop. That's as far as we're going to be able to go. We're not going to recover anywhere past that. Excuse me. So this is where things like having duplicate copies of all your backups comes in very handy, because you want to have mirrored copies of backups in a lot of cases for very key systems, because you want to make sure that we're not running the risk of losing any of these backup files. Because obviously if we lose any one of these transaction log files, we've lost everything. So a question I get a lot is, how often should we be backing up our transaction log? So this really depends on how much data you can afford to lose. If the business unit says we can afford to lose no more than 5 minutes worth of data, you should be backing up your transaction log every 5 minutes or more frequently than that. I like to go a minute or two less, because the business usually doesn't know and they're just picking a number at random anyway. So if they tell me 10 minutes, I'll back up maybe every 8 minutes. Just that gives me a little bit better window, and in the event that something bad happens, I look like the hero because I got back more data than I said I was going to be able to. And let's be realistic, it's all about making ourselves look good when something goes wrong. So we want those backups happening fairly frequently, and then we want to back them up to multiple places at the same time. How you do that, there's a couple of different ways. The easiest way is to use the mirror to command when actually doing a transaction log backup. So you literally just do backup log to some disk, mirror to some other disk. And it just creates the file in 2 locations at the same time. If that doesn't work for you or you don't want to do it that way, you can simply use some sort of SAN-based backup utility, or you can use robocopy or just the copy command and copy those files somewhere else. As long as we get them in a couple of places, we're going to be okay. Because the backups are obviously incredibly important because we need them to rebuild the entire system. The other thing we can do is what's called a page level restore. So when corruption happens in the database, it typically is not going to wipe out the entire file. It's typically going to wipe out 1 or 2 8K pages within the database. So if I've got, say, a 3 terabyte database file, do I really want to restore 3 terabytes worth of data just because I've got 16K worth of corruption on my disk? Doesn't make a whole lot of sense to do that. That's a lot of work and a lot of downtime. So starting in SQL Server 2008, I believe, we have the option of doing what's called the page level restore, where I can take my database backup, my full database backup, and I can tell SQL Server, do a database restore operation, but just restore this 1 8K page from the backup file and put it back into my database. I still need to roll all my transaction logs forward because I need to get that 8K page in sync with the rest of the database. But that's going to be a whole lot faster than actually trying to restore my entire 3 terabyte application. Now, I still have to take the system down to do this, but my downtime is going to be much, much shorter than it would be if I was doing everything else. We have the file group restore option as well, and I talked about this a little bit earlier, where again, we're simply restoring the specific files on top of, or the specific file groups instead of restoring the entire database. Now, something I get asked a lot when I do this particular presentation is, how do I do all these database backups? What's the easiest way to get database backups set up for a system that doesn't necessarily have them? Now, there's a lot of options available to you. The easiest one is the one that's built into SQL Server. And you're going to find that down here. And sorry, I don't think I actually have Zoom It installed. Let me see if I can zoom. No. So down here at the bottom left, we've got maintenance plans. So maintenance plans are not looked upon fondly by database administrators, but they're great for companies that don't have DBAs. So who works for a company that does not have a database administrator on staff? Don't be shy, it's okay. Nothing to be ashamed of. A few of you, okay. So for those of you who don't have DBAs on staff, these are going to make your life very, very easy to actually do your database backups, because you get a nice GUI to drag and drop and dump stuff into to create your database backups. For those of you who do have DBAs, you probably have some sort of maintenance thing set up already that they're going to use to set up all the maintenance for your system. So if you're going to use the maintenance plan, it's fairly simple. We just grab this task, if it'll let me. There we go. And we just drop it into the maintenance plan. So we drop in a database backup task, fairly straightforward. We open that up. We select what kind of database backup we're going to be doing, either a full or transaction log backup. So if you're going to be doing full recovery and you're going to do point in time recovery, so we need to do transaction log backups, you'd want 2 maintenance plans. One to do your full backups and one to do your transaction log backups. So in this case, we set the backup type to full. For the databases, we can select the databases that we want. I recommend just selecting that top radio button, all databases. We want to do our full backups on everything. If we're doing transaction log backups, the system database option is going to be grayed out because you can't do transaction log backups on your system databases. So when you set up this job for transaction log backups, again, either just select all databases, and that will automatically exclude the user databases or the system databases, or you can select all user databases, which again, it says it excludes master model, MSDB, and TempDB. You're probably going to want to check that box. Ignore databases where the state is not online, especially if you're using some of the more advanced functionality, database mirroring, always on availability groups, or if you take databases offline for maintenance or because they're not in use anymore, because that way it'll skip them and it won't throw an error message. Click OK. We don't want to do copy-only backups. Those are special. We don't want to worry about this backup set will expire setting. What this does is absolutely nothing useful. All this tells SQL Server is that if we set this so that they expire after 14 days, 14 days from now, I cannot read the database backup anymore. I can't restore it. This is not particularly useful. It doesn't delete the file. It doesn't do anything along those lines. It simply prevents SQL Server from restoring the data. Not helpful in really any situation. I don't know why that option is there. We're going to back up to disk, and we're going to back up across one or more database files. So we check that, and we can specify a database file. Now, if we specify a database file here, we're actually going to back up to the same database file every single time. We probably don't want to do that most of the time, because if we are backing up to the same database file every single time we do a backup, that file is just going to get bigger and bigger and bigger and bigger, because there is no way to delete backups out of a backup file. Your only option is to delete the actual file. So I had somebody on one of the forums once tell me that they had a 5 gig database, but their database backup file was almost a terabyte, because they'd been doing a full backup every single day to the same database file, and that file had just grown to a ridiculous size over the course of the last few years. And they wanted to know how to make that file size smaller, because they needed to keep the last like 2 to 3 months worth of backups, because that's what their boss told them they had to keep. So my answer to this was fairly simple. Rename that database file, or that backup file, so it's got a different name, so you're backing up to a new file starting tomorrow. And in about 3 months, delete that really big file. That's your solution. He did not like that answer. Fortunately, my job on forums is not to give you the answer you want, it's to give you the answer you need. So realistically, what you're going to do is select the one that was the default there. Create a backup file for every database. I personally recommend checking this little checkbox. Create a subdirectory for each database. It just makes it easier to manage the files and easier to see which files go with which database if they're not all in one giant folder. Especially if you're doing transaction log backups into the same folder, because then you're going to have lots of files to look at and to deal with. You've got the backup file extension right there, .back. See if I can resize this. No, it's not going to let me. And there's one more option down there which you may or may not be able to see under my taskbar. It says verify backup integrity. So that doesn't actually make sure that the backup is good. What that verify backup integrity checkbox does is it asks the SQL Server, once the backup is complete, to look and see if the backup file is corrupt. That's all it does. It doesn't check the data within the backup file to see if the data is actually valid. So if it passes this integrity check, you could still have a backup that's corrupt and can't be restored to the SQL Server. The only way to know that a backup is valid and usable is to restore it to another system. You don't want to restore it to the same system because A, you're going to overwrite your database if you're not careful, and B, that system may have some special driver or something that's going to let it deal with the file in some special way. So you always want to do test restores to another server, because that's the only way to know that your database backup is actually a valid database backup. And it doesn't matter how you're taking your backups, that rule still applies. And yes, that does require an awful lot of transaction log space, or an awful lot of disk space to make that work. Click, there we go. So database maintenance. Oh, yes, question.
Question about the old databases.
Mm-hmm.
You set up your own maintenance job and then later add another database.
Mm-hmm.
Do you include it, or do you have to redefine the job?
So the question was in here, if I open this back up, open, there we go. When I select all databases, what does all databases mean, basically, over time? If I add new databases, does it add them in automatically, or do we need to go redefine them? So as long as you've selected all databases or all user databases, it will get any new databases that you create. It will pick them up automatically and start dealing with them. If you select these databases and check all the boxes, it will not do that. Any new databases would then be missed and have to be manually be reconfigured, which is why I always recommend using either all databases or all user databases. What it basically is going to do is it's just going to run T-SQL and get a list of all the databases on the system, and then just loop through them, backing all the databases up. Oh, yes? Can you back up to another database? To another server? Yes, so you can back up to another server simply by putting a network share location in there, in that folder location. Now, keep in mind there are some bugs in Windows. Any Microsoft people in the room? So there are some bugs in Windows 2008 and below. If you're writing out to a network share, it's going to take a lot of memory away from SQL Server and give it to the Windows file system network driver. So if you've got really big databases, like hundreds of gigs, terabytes, and you're backing those up across the wire, it's going to take all the memory from SQL Server and give it to the file system. And you're going to end up with no memory for your SQL Server and really, really bad performance. What you need to do in those situations is write to a local disk and then copy it later by pulling it, not pushing it. Because the bug only affects when you're pushing data. It's really annoying. And it's a really big performance problem in a lot of cases. Any other backup questions? Awesome. So database maintenance. So databases need a little bit of love and a little bit of care, just like every other server in our environment. And they usually don't get it. The reason they don't get it is because SQL Server does not do any sort of database maintenance by default. You have to tell it to do database maintenance. What I'm talking about when I talk about database maintenance is index rebuilding or index defragmentation or defragmenting. It doesn't matter which one of these two operations you do. The end result is going to be exactly the same. That's the goal here, is to clean up our indexes. So what we're doing when we're rebuilding indexes or defragmenting indexes is we're taking care of page splits and we're taking care of fragmentation. So when we create an index within the database engine, we're basically resorting all the data based on whatever columns we've defined so that we can look up data faster. Well, as we are changing data within the system, we need to be able to track those changes in the index. Well, as SQL Server is doing this, it's not moving around lots of data. It's just doing the minimal amount of data moving that it needs to. So we end up with logical fragmentation of our index, where part of the index is on this part of the disk, and part of the index is on this part of the disk. So as SQL Server is trying to find all these pages, it's not able to do so very efficiently. So we need to fix this problem. And we do this through rebuilding or defragmenting our indexes. So when we rebuild the index, it literally just kind of creates a new copy of the index over here on this other part of the disk and frees up all these other data pages to be used later. So we get all in a big, nice, contiguous block of space being used for our index again. So this is obviously very good and very important, and this keeps the SQL Server running at peak efficiency. Now, there is one slight difference between these two operations, an index rebuild and an index defrag. That difference is statistics updating. When you do an index rebuild, SQL Server will automatically update statistics. And don't worry about statistics, I'm going to tell you what they are in a second. When you do an index defrag, it does not update the statistics automatically. So if you're working in a very, very large database environment and you're using SQL Server Standard Edition, you're not doing index rebuilds because you can't afford to take the database offline for that amount of time. So all you're doing is index rebuilds or index defrags, as they're also called. So if you're only doing the index defrags, you need to, on occasion, be doing update statistics as well. If you're doing index rebuilds all the time, every time, you don't need to worry about doing index defrags. So the reason we have two commands is because of what they're doing under the covers. I'll have that on the next slide. Index rebuilds, we're literally rereading all the data, writing it to a new location, and then deleting the old version of the index. That's basically what's happening. With an index defrag, we're looking at all the rows that we need to move, and we're moving things row by row around the index. On a heavily fragmented index, simply rebuilding the entire index is going to be faster and more efficient. On a slightly fragmented index, doing defragmentation is going to be more efficient and going to be faster. So we need to look at how fragmented these things are when we're making these decisions. Now on smaller databases, several gigs, 50, 60 gigs maybe, it probably doesn't matter because you're not going to get that much time saving. You're talking about saving seconds at that point by looking at which one of these different operations you're going to be doing. Once you get into the really, really big databases, hundreds of gigs, terabytes, etc., then it starts making a lot more difference as far as time goes as to which one of these operations you're going to be selecting. Now, as far as how you do these, there's a bunch of different ways you can do it. You can write your own T-SQL code to figure out what the fragmentation level of all these indexes are and start rebuilding stuff. I would not recommend going down that path. That's a lot of work. There's a lot of variables you need to take into account, especially if you're doing online index rebuilding in Enterprise Edition of SQL Server 2005 or higher. So your options become a lot easier when you start looking at either Michelle Uford's maintenance script, which is available on SQLfool.com, or you can look at Ola Hanegren's maintenance script, and I think his website is just ola.hanegren.com. Both of those folks have very, very good maintenance scripts that take into account fragmentation levels and whether or not you've got the Enterprise Edition of SQL Server or not, and that you can do online index rebuilds. You simply download those scripts, create them, run them against your SQL Server. They will create a stored procedure, and then just schedule that stored procedure to be executed once a day or once a week or however often you need to rebuild your indexes. Now, if your management's got something against running other people's code on your SQL servers, which is perfectly fine, we have another perfectly good option. Back to our maintenance plans. If we look at the toolbox again, we get an index rebuild task open. So very similar to what we had before. Select the databases that we want to use, all databases. And then we can simply say how much free space we want to leave in the index. You're probably going to want to leave that as default free space per page. And then you've got a couple of advanced options here. So this is SQL Server 2012. So this bottom one is new. Keep index online when rebuilding, when re-indexing. That checkbox has always been there. The two things underneath it, however, are new. For indexes that don't support online index rebuilds, either rebuild offline or do not rebuild the index. You're probably going to want to set it just like I've got it right here, because you don't want to randomly be taking indexes offline to rebuild them. So what I mean when I say taking an index offline is basically that means SQL Server locks the object. What it does when it locks the object is it prevents any other users from doing anything with that object. So if I'm rebuilding an index on a billion row table, that's going to take me about an hour and a half, give or take. So that means if I'm locking that index, no users can use that table for the next hour and a half. So nobody can read off of it, nobody can make changes to it. So obviously this means the application is down for the next hour and a half. Yes, sir? So his question is it the index that's offline or is it the complete table? So it would be the complete table because it takes the lock at the object level, which would be the table. So it locks the entire table so nobody's touching that table no matter what index they're trying to use. So once I click OK, I schedule this maintenance plan to run. It would then rebuild the indexes on whatever frequency I want. Now, if you want to see what this is doing, you can actually click this View T-SQL button. So I didn't talk about this button on the backup one because the screen resolution of the projector doesn't allow you to see the button. So if we click the button, we literally get the exact T-SQL, or at least very, very similar T-SQL to what is actually going to be executed when this maintenance plan runs. So all it's literally doing here is just generating a bunch of alter index statements, and then it's just going to run those statements one at a time as the maintenance plan is running. So when you've got large databases that you're working with, it can make a lot of sense to do the index defragmentation, because there's one more difference between rebuilding and defragging indexes. Index rebuilds are a single large operation, which means that if I interrupt the operation rolls back. So if I'm rebuilding my billion row index, it's going to take an hour and a half, and I stop it 1 hour and 25 minutes into it, it rolls the entire command back, and the index is the same index it was before. Index defragmentation, on the other hand, is not one big operation. It's actually a lot of really little operations. So what happens when the exact same thing is done, an hour and 25 minutes in, and I stop the index defrag? We don't roll back. All the changes that were made, all the work that was done remains in place. When I go to defrag the index again the next night, we simply start from where we left off, or basically where we left off. We just start with all the rows that we need to move starting now. So if you're in a situation where you don't have very much maintenance time overnight to run your index maintenance jobs, it might make sense to simply schedule defragmentation jobs, run them for, say, an hour, and then have something that stops the job. In it, just wherever it is, just stop it. And then we'll just continue the next day with cleaning up more data. And you end up in kind of this never-ending loop, but all your data eventually gets cleaned up that way. So when you're doing index rebuilds, these can be online or offline, depending on the version of SQL Server you're running, and depending on the edition of SQL Server you're running, and depending on what data types are in the table that you're trying to do your index rebuild on. So online index rebuilding was introduced in SQL Server 2005 as an enterprise edition feature, meaning you've got to pay for the big expensive version of SQL Server. That requirement has not changed up through SQL Server 2012. I would not expect it to change in SQL Server 2014. It is probably one of the things that drives sales of the enterprise edition of SQL Server, so don't expect it to change anytime soon. If you're using text, ntext, image, var binary max, varchar max, nvarchar max, or XML data types, online index rebuilding does not work in SQL Server 2005 through 2008 R2. Starting in SQL Server 2012, the ability to do online index rebuilding when using any of those data types that I mentioned is now supported. So if you've got a large table, there's the back of the stage right there. If you've got a very, very large table that you need to do online index rebuilds on, and you can upgrade to SQL Server 2012 Enterprise Edition, then you'll be able to do online index rebuilds. But using any of the older versions, you won't if you're using varchar max and varchar max, etc. So like I said earlier, it basically just creates a new copy of the index and drops the old one. It's not exactly what it does, but you get the general idea. Talked about that already. So the nice thing about doing defrags is that the operation is always online. It doesn't matter what kind of data it is, doesn't matter what version of SQL Server it is. You can be running this on SQL Server 6.5, God help you if you still are, and it'll work just fine. So, as I promised, statistics. So statistics are very important to SQL Server because they tell SQL Server how to find the data that it's looking for. So when you write a query in SQL Server needs to know how to go find that information. It knows what table it's in, but it needs to figure out what index to use to go find that data. How it does that is based on statistics. The statistics are then used to create the execution plan, which is what's going to be used to actually go get the information that you're looking for. So the statistics themselves is just basically another kind of hidden table in SQL Server. And that table contains a sampling of the information from your regular table. This statistics, so this sample table, contains up to 200 rows. That's it. If you've got a billion row table, there are 200 rows in the statistic that keep track of what's going on. So statistics and keeping the statistics up to date is very, very important when it comes to database maintenance. I've had several clients that have brought me in to deal with performance problems. Literally, all I've done is update the statistics on their database and walk away. Problem solved. 20 minutes, done. Have a nice day. It's that easy a lot of the time. Now, how you know the statistics are out of date, that can be a little trickier. And I'll show you how to figure that out in a second here. So here is the output from a statistic. So this is using the command dbcc show statistics, and it's a fully documented command. You can see it in books online, how to use it, what all the parameters are. When run as the full output, it's going to dump you 3 different record sets. And this is just a record set or an index straight out of AdventureWorks. So at the top there, hey, laser pointer. We can see the name of the index that the statistic was created on. By default, the name of the statistic will match the index. If this is a real funky looking name, then either somebody created it manually, or it's an auto-generated statistic that doesn't have an index that goes with it, which is totally possible and perfectly okay. This updated date, this is going to be one key that tells you how old the statistic is. Because whenever you do an update statistics, that date gets changed. So obviously, this is a fairly old index because it hasn't been updated since March 14th of 2012. That being, about a year and 4 months ago. So if this were my production system, I would probably want to update the statistic if queries that were using this index were running slowly, just based on how old that statistic is. Now, if the data in the table has not changed, say it's a reporting environment for a stale system that no new records are going into, updating statistics is not going to solve any problems because the data is not changing, so the statistics are still current. So we can see how many rows there are, how many rows were sampled as part of this statistic. So when SQL Server looks at really large tables and updates statistics on really large tables, it does not read the entire table. It does not scan the entire table to generate the statistics. It looks at a small sampling of the data, typically about 10 to 12% of the data, and it generates the statistics based off of that sampling. So in other words, it's a sampling of your table. So it's not going to be perfect, but it's going to be good enough most of the time. Now there are occasions where it's not good enough most of the time. Where that's going to happen, where it's not going to be good enough to just have this sampling done, is tables that have very, very skewed data distributions. So say you've got a customer's order table, and you've got one customer that's put in 1,000 orders, and every other customer's put in 1 order. Let's skew it a little more. One customer's put in 1,000,000 orders, and every other customer's put in 1 order. When the statistics are built, if it's just taking samplings of the table and it doesn't sample that specific customer's information, the statistic's not going to be accurate because the data is so skewed for that one customer. So in that case, when we do our update statistics command, we need to tell SQL Server to do a full scan, which simply means putting with full scan at the end of the update statistics command. So you can see how many rows were sampled when this statistic was created or when it was last updated. Because it's telling you right there. There were 121,317 rows in the table, and it read 121,317 rows. So it sampled the entire table. In this case, full scan was done. The number of steps that it's talking about right here, this is simply how many rows there are in this third record set. How many steps there are in this statistic. Average key length is how wide the values are. Is it a string index, yes or no? If it's filtered or not. So starting in SQL Server 2008, we can create filtered indexes and filtered statistics. Typically, when you create an index, you're creating the index for every row in the table. When you put a filter on there, you're basically just putting a where clause on the index, removing rows from the index. So if you have a filtered index, you have a filtered statistic as well. In this case, it would tell you what the filter was, and then how many rows there are in the total table compared to within the filtered part of the table. The second piece here tells you what columns are included in the statistic. So there's 3 rows here. So the bottom one is all the columns that are included in the index. Product ID, sales order ID, and sales order detail ID. Now the bottom piece is the interesting piece because this is the actual statistics information. So this is the part that SQL Server is looking at when it's running queries against the system. So there's 5 columns there: range high key, range rows, EQ rows, distinct range rows, and average range rows. So the range high key, that is the highest value that is being represented for that row. So because we're using integer-based numbers, this is fairly easy to read. The range rows is the number of rows being represented by that value that are not that specific value. So it's 0 for most of those because there's only one value in the table for each one of those numbers, except for the range number of 718. So that would be product ID 718 within the sales order detail table has 218 other rows that match that specific ID number, which means EQ rows is 219, because that's how many rows there are that actually match that specific value. Distinct range rows and average range rows, those are internal numbers that say how these things match up, if they're distinct or if we're doing this based on average values of these specific IDs. I honestly don't know why it's set up this way. Microsoft built the index, so I can't take any credit for it. But this is the information that SQL Server is looking at. Now, this information, like I said, needs to be kept up to date. The problem is it doesn't get kept up to date very often. By default, SQL Server updates the statistics automatically when 20% plus 500 rows have been changed. So if we've got a small table, 10,000 rows, that means we're updating when 2,500 rows are changed. Not that big a deal. If it's a little out of date, yeah, that's okay. It'll figure it out. On larger tables, however, this starts to become a problem. Say we've got a 10 billion row table, and we need to wait for auto update statistics to kick in. Well, that means we have to wait until 2,500,000,000 rows have been changed. This is going to take a while. In Microsoft's SAP environment that they use to run their business, because like every other large company, they use SAP, when the new year would roll over and January 1st would kick in, the new year would not show up in the statistic until August. So whenever they were running reports for the current calendar year from January till August, SQL Server had no idea where this information was. So it had to go find it. So to fix that, Microsoft put a new trace flag into the system that will change the algorithm. And I don't know that trace flag number off the top of my head. I think it's 3291, but I'm not positive. What that trace flag does is it changes when SQL Server is going to automatically update this information from 20% plus 500 to a sliding scale. So the sliding scale starts at 25,000 rows. So from 0 rows to 25,000 rows, it's the normal 20% plus 500. Once you get to 25,000 rows, the percentage requirement starts getting smaller until we get down to about 0.01% of change required. So this means on the really, really big tables, we don't need to update that many rows compared to how big the table is to actually get the auto update statistics event to fire. So this makes our maintenance much, much easier for these larger systems and these larger tables. So a nice new feature that we have in SQL Server is data compression. So this saves space in a few places. The biggest one and most important one being the database itself. There's two different ways you can do compression. The one you're going to be using the most to get the most space savings is page level compression. Now, the downside is this is an enterprise-only feature. But if you've got it and you can use it, it will save you quite a bit of space for a very, very low cost. That cost being CPU time. I've got a customer that's got right now a 2-point-something billion row table. It was a terabyte. When I turned on page compression and rebuilt the table, it shrunk down to about 300 gigs. CPU load on the box went up by less than 1% by turning on compression. So CPU goes up a little bit, massive space savings. Very, very worth it because they were starting to run out of space because it is a 2 billion row table that takes a terabyte of space. When we turn on compression, we also save space in memory as well. So SQL Server uses lots and lots of RAM. That is intentional and by default. It uses this memory to hold a copy of the data off the disk so that when we're running queries, we don't need to go read the data off the physical disk over and over and over again. By turning on compression, because we're putting more data in each 8K page, we can put more data in each 8K page in memory as well, because the data that's in memory is compressed when it's sitting in memory. It's not decompressed until it's actually being processed by the storage engine. And that's when it actually decompresses it, reads the rows, and actually does something with it. But when it's just sitting in memory waiting to be used, it leaves it in a compressed state. Because the data is compressed in our database, it's also compressed in our backups as well. So like I said, there's two options for compression, page level compression and row level compression. So row level compression is only going to work on numeric values. Page level compression is going to work on text and numeric values. If you're using Unicode data, you need to wait for SQL Server 2012 to actually get Unicode compression, because Unicode data does not get compressed in SQL Server 2008 R2 and below. So the other compression option we have is backup compression. So backup compression is very, very handy because it compresses your database backups. Fairly straightforward. The other nice thing, this is a standard edition feature. So if you're using standard edition, you can make your backups smaller simply by turning on this backup compression setting. So you can set that setting in a couple of different places. The first one is on the properties of the instance. If I remember right, it's down here at advanced. Where did it go? Okay, I'm wrong. It's not advanced. All right, I can't remember where they put it. There it is. Database settings, because that makes perfect sense. So that checkbox right there. Turn that checkbox on, and by default, all your backups will be compressed. You can also, if you're using a maintenance plan, there's a checkbox in there as well. It's on the bottom of the screen. You can't see it because of the resolution. That says compress backups as well. Or actually, I think this asks what compression option do you want to use, default, on, or off. So you can specify it there. By default, it's going to read this setting and just use this setting. If you're writing your own backup commands, all you need to do is do with compression as part of the T-SQL statement, and then the backup compression will just be turned on for that particular backup. So it's fairly straightforward, saves you a decent amount of disk space. Now, if you're using transparent data encryption to encrypt data within your database, you need to be very careful about which one of these compression options you're going to use as to how much space they're going to save you. If you're using row or page level compression with transparent data encryption, it will work just fine, because it's going to compress first and then encrypt the data. If, however, you're using transparent data encryption and you turn on backup compression, when you do the database backup, you're going to save almost no space, because the data is already encrypted when it's being backed up, which means that basically no space savings is going to happen, because there's no duplicate data to compress. So database corruption, the bad news. All databases can and at some point will probably become corrupt. It's just a matter of you catching it. Corruption is almost always a hardware problem. I've said this to storage vendors, and they've all agreed with me. If they're not agreeing with me, that's because they're lying to themselves. Corruption should be checked for extremely regularly. We check for corruption by using something called the DBCC checkDB command. Depending on what is corrupt and how much corruption there is, we may or may not be able to repair it without any data loss whatsoever. Basically, if the corruption is in a non-clustered index, we can fix that no problem, so there's no data loss. If the corruption is within a base table, the actual table itself, odds are there's going to be data loss for us to fix that, because we're basically just going to wipe out the page and remove all the links to that page. So you are going to lose rows. It's up to you to figure out which rows you're going to lose. And there's a couple of different ways you can do it. The easiest way for smaller tables is simply fix the corruption, restore a backup to another server, run queries to see what rows are missing, and then just copy in the missing rows. Fairly straightforward. When you run the DBCC checkDB command, it's going to tell you what repair level is required. And there's a couple of different repair levels. The one that says allow data loss means that you're going to lose data. It was named that way for a very specific reason. There's a lot of rumors on the internet saying that it doesn't allow for data loss, or that all the other repair levels can cause data loss as well. No, they can't. If you repair it with a repair level that does not say allow data loss, it is not going to lose data. It's fairly straightforward. Now, repairing a database that's corrupt does require an outage. You are going to have to put the database into single user mode so that CheckDB can fix the problems. But once it fixes the problems, you can turn the database back on and your users can come back in. Corruption is going to happen. Happens a lot, happens all the time. There's forum posts about it every single day. Honestly, I have no idea how these people corrupt their databases this badly sometimes, but it does happen. Almost all corruption can be fixed. The exception to that is if your system tables become corrupt. If the system tables become corrupt, and the system tables are the tables that contain the actual schema of the other tables, if those become corrupt, there is no fixing it. Your only option is a full database restore. So this is why we have to have those full backups, because if we lose those few pages at the beginning of the database, all bets are off. So when I say corruption is usually a hardware problem, I'm talking 99.99% of the time, it's a hardware problem. The other 0.005% of the time, it's bad memory. And by hardware, I mean disk. 0.005% of the time, it's bad RAM. The other 0.005% of the time, it's a bug in SQL Server. Knock on wood, or knock on plastic, there has not been a storage engine bug that causes corruption in SQL Server since SQL Server 2005. The guys that write it, who I go drinking with regularly to keep them well lubricated and keep them doing what I want, are very, very careful about what they put into their code base. And they do not touch this thing unless they have to, which is why we haven't had a storage engine bug since 2005. Excluding SQL Server 6.5, because that thing could corrupt the database if you sneeze too close to the server, there have not been any real major serious production level show-stopping bugs in the database engine since then. 6.5 was an absolute disaster. If you've never worked on it, be very, very happy. So I've got a couple of minutes left, so I'm going to kind of burn through these next couple of sections. Compatibility level. The compatibility level is a setting within the database, and it tells the database engine what language syntax version to support. When you attach a database from an old version of SQL Server to a new version of SQL Server, it automatically sets the compatibility level to the old version that it was connected to, because that's the version syntax that it knows will work for the application. If you need to use new commands past that, or the new language syntax on that, you'll need to change the compatibility level. This does not affect what version of the SQL Server you can restore a database to. Very common misconception. If I've got a SQL Server 2012 instance, and I've got a database that's in 2005 compatibility mode, it supports the 2005 syntax. I cannot take that database, back it up, and restore it to a 2005 server. It is a 2012 database. I know this because I can take the compatibility level, I can change it to 2012, and then I can change it back to 2005 if I need to. SQL Server supports several down-level versions. SQL Server 2008 R2 and down support all the way back to SQL Server 6.5. So you can go quite a ways down. SQL Server 2012 supports the SQL Server 2005 compatibility level and up. So 05 to current. SQL Server 2012 or 2014, I don't know what it's going to support. My hope is that it supports 2005 and up. The reality is it may only support 2008 and up. So it all depends on what Microsoft builds into the product. Indexes. So indexes are used to speed up queries when we're running our queries. They're sorted based on the indexes, or based on the columns that we put within the index. So this is how they speed things up. We simply are reading the table and restoring it sorted in a different way. And we are causing duplicate data to be stored because of this. So basically, we're trading space for speed. That's what it basically comes down to. Hey, look, that's the next bullet point. Creating indexes is kind of half art, half science. When you start creating indexes and start doing index tuning, it's going to feel like voodoo. That's perfectly normal. Once you get the hang of it, it becomes a lot more intuitive fairly quickly, and it'll become a lot easier to do. But when you first start out doing it, it feels a lot more like art than science. So there's a few different kinds of indexes that we have available to us. Just get them all on the screen here. Clustered indexes, those are your base tables most of the time. When you create a primary key on a table, by default, that primary key is going to be the clustered index. So the clustered index is the actual table if there's a clustered index on it. Non-clustered indexes are what you're going to be creating most of the time, because those are going to be how you're actually building these indexes, how you're doing your tuning itself. Full text, spatial, column store, XML, and semantic, those are all more advanced options that take a little bit more work to actually get through. I don't have time to talk about this because my timer is flashing saying that I'm done. So I'll talk really fast here. Indexes are not free. They do slow down your insert, update, and delete operations. Every time you add an index, all your writes are getting slower because we're doing more writes. You've got some homework up on that URL. You've got some additional things that you're going to want to read about. They're going to talk more about all the stuff that I've talked about over the course of the last 76 or so minutes since I'm now over. The slide deck is obviously going to be available online on Channel 9, as is the recording of this session, so you can grab it there. If you don't get a copy of this URL now, feel free to grab it from me later. There's my contact info. I do have business cards up here as well. Please do submit evals from this session as well as all the other sessions. This is how, A, we know how we did, B, how Microsoft knows who to pay to fly all the way over here, and all the way over to the US for the guys from Europe that go to the North American conference. You either hit the QR code here, which I'll put back on the screen in a second. Okay, that's the last slide. Or you can just go into ComNet on the TechEd website and fill out all the evals there. Thank you all very much for having me. I appreciate you coming to see me at 8:30 this morning, and enjoy the rest of TechEd.